No, but how you will say this complete data is corresponding to the address A1. Now let's say no, no, no. We have the A2 address with 2. Size is same, length is same. Uh, Length 6, no? Take it as 4. Now D1, D2, D3, D4. Hmm. Things are clear now. Like we have the two requests with the different IDs. Now we can identify on the right address channel with the help of ID. Okay, these particular beats are coming for the address A1. The slave get to know, okay, this particular data beats are getting for the address A1. After that, a new address is coming. So the WID is 2. So it will corresponding to address A2. Same is with the response channel. Whenever the slave is giving us the response, so it will tell us what is the BID. So it will give us the responses for the BID as 1. So the master will get to know that the for the address A1, the response is there. After that, maybe at response for A2. Oh,
The response will come for only a single cycle, right?
yes.
Uh, the width of the WID and address ID will depend on how many addresses are possible.
No. So now there's a question over here, like what should be the width of this AWID, WID and BID? What is the possible width? So it is totally a user dependent thing because all the IPs have their own like restrictions. There can be of 32-bit. It is also possible IP support only a 2-bit. So it all depends on like how many outstanding transactions it can control. Okay, because like if we have only a 2-bit, so and a unique ID can be only have 4 possible values. Okay, so there is a possibility, like it all depends upon the user. What should be the width of this IDs? But yeah, address is 32 or 64-bit. Yes, team, any doubt on this sheet, like how the address is going, how the data is going, and how the response is going for the right address, right transfer?
I have a question.
Yes.
So in read operation of ASI, we will have the read last signal.
Yes, this last signal.
Read, we will have read last signal. So when read last
No.
signal will activate,
Mhm.
when we will send the read last signal from the slave to master.
Mhm. So you're asking for R last.
Yeah, R last.
Mhm. So the same thing is with the like on the response read channel as well. So whenever the all the read data is going, so at the last beat it will generate the R last.
So will the R last will affect to the ready signal from the slave like
No, there is.
if
Mhm.
like if it's
Yes.
not done read the, we if we're waiting for the last signal turn on, then it will send the ready signal.
Mhm. Okay, so we'll consider example over here only. So let's say for address channel, W last is 000, and over here it is 1 0 0 0. Now this is 1, valid is 1, but ready is 0 for multiple cycles. So R last will also being asserted for multiple cycle until and unless this ready gets high. Like this will be a transaction. Like this is the transaction being generated by the master, that validate is here D2 D4 on a WID. Okay, this is the last beat, which is like telling the master is telling to the slave, master is asserting the valid, but slave is not asserting the ready. Now, until and unless the ready gets high, all these signal state will keep the same. Same thing will happen in case of read channel. But the only thing is we have the R data, R valid, and R ready. So in R response. So until and unless this valid is asserted by the slave, whenever the master is ready to take it, the R last, R data, R valid all will keep the high on the bus.
Okay, so I got it.
The size and length are also present in read also.
हाँ हाँ हाँ.
We will give the starting address
तभी
and
तो
size and
like we'll get to know ना कितना data master
like
will
bus
get.
read.
All things of this will remain same as there are multiple states. इसमें same ही रहता है.
Sir, अगर हमारे पास एक single, if there is a single master and multiple slaves, can a single master continuously drive different transactions on different slave at the same time, like read and write transaction continuously at the simultaneously to different slaves? Possible, right?
But not to write transactions simultaneously.
It will be back to back
It
ना.
will be back.
A1 A2 A3 A4. Every
Right.
like in EXA protocol, we if we are communicating, okay, one thing like EXI is only about a master to slave. Okay, there is only one master, one slave protocol.
Okay.
Okay, if we have multiple masters, M1, M2, and S1, S2, S3, and we want to communicate all of them through the AXI, so there must be a knock or interconnect in between. Okay, so whenever this master is giving the transaction to knock M1 and M2, this is a independent AXI. In the knock, there is a slave of AXI. In the knock, there is a master, three masters of for the slaves,
Okay.
which is communicating. Okay, this thing is clear to you. Like whenever we are talking about the multiple master, multiple slave in AXI, so there must be a knock, because like what why I'm telling you, in AHP and APB there is a concept of single master and multiple slaves. So a single master can communicate with the multiple slave, but in that case also there is in between there is a logic as a basic address decoder. Everyone knows about what is address decoder basic. Okay, so whenever a master is generating a request, it is decoding the address which slave boundary it is lying to. So this concept is there in AHP and APB. But when we talk about the AXI, if we have single master only or multiple slaves, so there must be a interconnect in between. All the four protocol channels are different. These AXI1, AXI2, AXI3, 4, 5. All the interfaces are different.
Can we give a address only and it's duty of the knock
It's
that,
the duty of knock.
that which address boundary it lies.
Hmm.
And if it doesn't lie in any address boundary, it will throw a decode.
Decode. Any questions on this, like how the AXI is being connected in multi-master, multi-slave?
इसमें क्वेश्चन था ना, जैसे मास्टर वन है अपना, तो उससे S1 पे हमने एड्रेस इशू कर दिया और S2 पे डेटा इशू कर दिया, तो सेम टाइम में हम ऐसा कर सकते हैं, like can master one issue the address to the S1 and data to the S2 at the same time.
Data of like
Data S2 पे कोई write करने के लिए
different, हाँ possible है,
और उस पे एड्रेस इशू कर दिया उसने
हाँ
सेम टाइम पे,
हाँ possible.
So ये
Same time पे
30
तो address करेंगे तो that will be on a
Okay.
priority basis.
Okay.
But channels तो different है, right?
Channels different है.
हाँ, तो address में priority basis.
Priority किसकी?
I mean, this is two master file slaves my random. I have randomized all of my output that they should be sending multiple transactions together. तो ऐसा नहीं होगा of course कि master one will be waiting for completion of transaction. They will simultaneously be sending each other. तो master one में suppose slave 2 और slave 3 पे साथ में भेजा, तो that will be like together. But अगर master 1 master 2 ने दोनों ने साथ में slave 2 पे भेजा,
then it's
that
on
will
the
be on a
priority.
basis.
Correct. Okay, so now over here we have a question like let's say on this interface we have generated a address request, and at the same time we have generated a data over here. A data is coming without coming of the address. That's what you're saying, na? Sure. नहीं, address नहीं आया है. Without address. So, like, can anyone tell, is this possible or not?
So you mean that the right address come without? So can you repeat the question?
Yeah. So the question is like we have the request. Some request is coming. Multiple requests are there from master. Knock have the multiple like buffers. So which is holding the request. Now further on this S1 interface, the address is being generated. A write request is generated. And at the same time, on the S2 slave, a write data is starting to drive. Okay. And this data is coming without the address. So the address request is not there, but still the data is start driving of this S2. Is on, and both of them are happening on the same clock. Is this a correct scenario or is there any flaws in this?
Not a correct scenario.
It is a correct scenario.
No, not correct.
What is the issue in this?
Because the slave to run without the address. So how can it write the data? Or it write the data to where?
Okay.
Like sir,
Fine.
without address,
And,
how the slave can recognize the data? Data should
Okay.
be, sorry, address should be there. I think.
So for this, I'm sharing the specification. I'm not drawing it. Actually, I'm not told till now. There is a dependency, whatever the ready wallet we have seen, na? Among the channels also there is a dependency of this ready valid. No, uh,
These
okay.
are independent, na? These are
हाँ.
independent.
So there is a difference in AXI3 and AXI4. Now we are all are aware of this AW valid, AW ready, W valid, W ready, B valid, B ready. This is for the write address channel and for the AXI3. Now you can see there are two types of arrow. One is a single headed and there is a two headed arrow. What a single headed arrow means, like A valid can assert before and after the ready. Okay. Whenever the ready is high, A valid can be high or low or vice versa. But double headed arrow means B valid can be high only when the valid and ready is high. W valid and W ready is high. After that only the B valid can be asserted. Okay, you
Uh,
can read out this point. The slave must wait for both W valid and W ready to be asserted before asserting the B valid. So this is the must scenario, but it can be possible for W ready and W ready. Now, I'm like, I just, yeah, you were saying something. You just first asked. Yeah.
so for this diagram, there's
Mhm.
the address and the data not need to come at the same time, right?
The data is need not to come at the same time. Address and data.
Yeah.
Yeah, that's what I'm saying. Now, what are the different scenarios we can see with this diagram is first thing. Firstly, the address is coming. Okay. The default scenario we have seen. The address is coming. After that, the data is coming. W ready, W valid, all are high. After that, the response is coming. We are completing the simple. This is a simple transaction. Other scenario is because there is no dependency between the W valid, AW valid, and W valid. So W valid can assert before the AW valid. In the diagram, we don't see any double-headed arrow for this W valid. If there are dependency on W valid, that it must be high on after AW valid. There is no such dependency. So the data can come before the address is being driven on the address channel. Okay.
Yes, sir.
So this is for the AXI3. Like on the W valid, data is coming, and after that the address is driving, and in the end the response is generated. This is the second scenario. Now that what is the third scenario in this? Firstly, the data is start driving. Okay, and after completing the data, we are just start driving the response, because on the response also we don't see any dependency of the address. You're seeing there is no double-headed arrow of the address on the B valid. So the third scenario is W valid followed by the response followed by address. Okay, first is address, data, response. Second is data, address, response. Third is data, response, and then address. And fourth one is data is coming, response is coming, and address is not driven because there is no dependency. There can be flaw. You can later on you can read all the points. You'll see all these 4 scenarios will be covered in this. So this we are talking about the AXI3. Any doubts on this? This is very important, like how the all the 3 channels, these are interconnected. Should I explain again or any question on this? Yeah.
So, for this for the transaction after the P, so for example, the master one start the right transaction to the slave one. So after the response is sent by the slave, the master. So after that, the master can send the other transaction, right?
Yes, that is a scenario. But yeah, like you're saying, after the address from master one to slave one, response is completed, and after that we are sending another address. That's what you're saying, na? That
Uh,
is a possible case.
okay, sir.
Hmm.
Hello.
Yes.
Hi, sir.
Hello.
So in the fourth scenario, if the address is not coming from the master side,
Hmm.
then that transaction is dropped by the slave.
Yes, because it don't the slave don't know where to store that data.
Okay.
It will wait for some time. It will keep stored in their buffers. But if we don't, that is the implementation specific thing, how the slave is going to handle that particular transaction. Because there is a possibility after multiple transaction, we get the address with the same ID. So there is a possibility the address will come later on, but after maybe a timeout is there. So for that transaction, it can empty their buffer then.
Okay.
कीबोर्ड एरर
Hmm?
अगर एड्रेस नहीं मिला
नहीं.
नहीं कोई error नहीं Then in the third scenario, like data, then response, and after that address. So in this, how will it save the data if the address is coming after the response?
तो वो अपने buffers में store रखता है ना data को.
Okay, it will wait for address in the system.
सेम आईडी पे आएंगे ना
Just a second. Huh? Just give me a 1 minute. Huh? There is a call. Yes. So yeah. Now, like if we see the AXI4, AXI4 and 5, so there is a slight change in the diagram. Now you see the address valid, both are same, everything is same, but on the B valid, they have added the dependency of the AW valid and AW ready as well. There is a two-headed arrow on the B valid.
And still in the XI4, we can issue the address and data at the same time.
Like आगे पीछे हो सकता है.
But response नहीं आएगा.
Response
तब
नहीं आएगा.
exist.
Okay. So what the scenarios, what scenarios will be changed? Only the last scenario we have discussed over here, na? Like this fourth scenario, because this is a invalid scenario. Like the data is coming, response is coming, and the address is not there. So this to overcome this scenario, we have overcome in the AXI4 protocol, 4 and 5 for the further protocols. Rest will be the same.
सर सेकंड केस एक बार प्लीज एक्सप्लेन कर दो दोबारा सर.
Second case is like, firstly, the data is coming on the data channel, particular data is coming, and after that, the address is generating for that particular data. Like if we see in the sheet, like this is the first data, na? D1, D2, D3, D4. This is a first burst. So A1 address is not coming over here. The address is coming after over here. This is the possible scenario.
And after that, then sir, valid and ready will come.
Yeah, I'm considering valid and ready are high at this point.
Okay, sir. Before B response, sir.
Yeah, before B response.
Both the read and write channel response, these should be
Hmm.
high. Address and data.
Yes.
Okay.
Tushar, is third scenario is valid in XI4?
Third scenario.
I think third scenario cannot happen.
Third scenario is like we have the data, response, and address. No, third scenario is not possible for the AXI4 and 5.
Okay, well, and only two scenarios are valid. First and two.
Yeah, only two scenarios. Like one thing is the address is there, data is there, and then the response is there. Second one is like the data is there, after that the address, and then the response. Only address and data can be interchanged.
Okay.
Okay, so that's how we are like there is a write address. Then there is also a diagram for read as well. So this is for the read transaction. In this we have only two channels, read address and the read data. So in AXI 3 and 4, it is the same. After the address is completed, then only the read will start. So there is no complexity in this. Okay. Any doubts on like channel dependency, because you can like later on we can you all of you can read how the dependency are there, how the channel handshaking is happening, because the scenarios like in further all the scenarios may be occur, like the address is coming, the data is coming, because whenever the interconnect is there, it can route the transaction in its own way. Firstly, it can send the data, then the address, and in the outstanding addresses are there, data is coming later on or in between. So all these possible scenarios can be there. Okay. So no more doubts on this.
No, sir.
Okay. Anyone else? that how?
No, sir.
Okay. So till now we have
So Tushar, back to that question, that scenario is valid in both AXI3 and AXI4, right?
back to that question. Like this scenario is possible because firstly, both the interfaces are independent. Okay, the first thing is both of them are independent, so we cannot like create a dependency on these two interfaces. The main question was over here, like, can the data be appear without the address? Yes, it is possible, but now it depends upon the interface whether it is a AXI3 or AXI4. That we have to check, but the data can come before the address.
दोनों पे possible है ना?
Hmm?
एक से ही 4 3 दोनों पे.
Response.
But response, whatever all the scenarios we have discussed, but the scenario is a valid. Okay. Burst beat difference is clear. Multi-master, multi-slave connections are clear. Channel dependency. Any doubt on these topics? How a transaction is going, a particular transaction is happening on the interface. Hello. हाँ sir. Okay. So now we can go back to like burst. What is a fixed burst, increment burst, and a wrap burst? I think अभी ये सिर्फ burst से cover up कर लेते हैं बस. Okay. Then we schedule in the next class. So anyone can explain what is a fixed burst?
Repetitive at the same address.
I think for the big bird, the data will be right into one address. It's not increase. It's not increase bit by bit.
Can you repeat? Sorry, I didn't get your.
I think for the fixed bus lane, the data will be right into the star address.
Yes.
For the increment, the address will be increased bit by bit. And for the graph, so for the graph, it will if we have well to one window, if the data is out, it will return to
The wrap boundary. Yeah. Correct. So now we consider one example for fixed and INCR. Okay. So let's say this A1 address is 0x some 04. So over here, when we have generated an address 04 with a fixed burst and length is 3. So firstly, I'll tell you about the length. Whatever the length is there, length is always like AW length. So if we are providing the 3, so final beats will be going 3 plus 1. So 4 beats will be generated on the burst. So whatever the value we are providing, we'll add a 1 to it that number of beats we are transmitting on the interface every time. Okay, if we have 8, then 9 beats are there. We have 7, then 8 beats are there. Okay, this is just a basic thing I just want to add. So AW length is 3, so 4 beats are there. Now, in case of the fixed burst, now over here I'm just creating, let's say, a memory, let's say, how the data will be stored in a memory. So this is adder and this is our data 0 cross 0 0 0 4 8. Okay, so what will happen in case of fixed burst?
Address will not change.
Address will not
Will not
change.
change.
The data will keep written at the same location again and again. First, the D1 is written. Okay, let's say it will be a 32 or 64 bit. Then again on the same location, it will write D2. On the same location, it will write D3, D4. So all the data will be written on the same address. So what is the usage of this particular burst type? Because we are writing on a same location again and again, what is the advantage of this type of burst? Hmm?
We will not have to send multiple address.
In AXI, we are just sending single address only, starting address. Even for INCR and RAP, we are just sending the starting address.
When the beat size is smaller than the data bus width.
Beat size is smaller than,
Beat,
but the data is overridden. It is not, we are not concatenating the data.
The memory size.
Memory utilization.
suppose we have to
You're not
write
getting the
only a single
question.
beat.
The width of data over here is, let's say, 64 bit, 63 down to 0, or 32 bit, let's say, basically. Okay. We are sending all the beats are of 32 bit only. This W address is 31 down to 0. Can anyone tell like what is the advantage of this fixed burst? Because we are sending the first beat, it is storing at the 04. Second beat is over here. The last data it will store is D4.
So it is continuously reading from the same address.
If we
So, like from a single address. So if there is a FIFO basically, and it is continuously reading from same address and storing it.
So how a FIFO works basically? If we have a FIFO, it will have only a base address for this FIFO. Okay, so let's say the base address of FIFO is 0 cross 04. Okay, so if we have to store a data in a FIFO, we cannot access the like different locations of a FIFO. We only know the base address of it. Okay, so whenever such kind of memory or buffers we have to access, we can use the fixed type. So what happen if we writing multiple bit? It will just pushing back the data. So the FIFO will contain the 4 addresses D4, D3, D2 and D1. This thing is you're getting this thing how the what is the usage and advantage of the fixed burst type.
It only have depend on when we use FIFO. Uh, This.
So every time it's not necessary we have a memory like this.
Oh,
There can be
okay.
a possibility we are accessing some kind of buffers. Correct. The slave have the memory, or it's not necessary the slave is containing this such kind of memory. There is a register, there is a buffer that we are accessing. There is particular uh, any any address map. It can contain different types of storage. So if we have a FIFO, if we have a LIFO, some kind of that thing is there. So they have their own base address. There is just a base address to it because we cannot accessing the because it is unbounded. We don't know the size. We cannot have the irregular elements in that FIFO. So whenever we are accessing the first address, it is just pushing the data back to back. It is storing all the data.
Oh, okay. I understand, sir.
Yeah.
स्लेव में पीपो भी हो सकता है और मेमोरी भी हो सकती
हाँ.
है दैट स्लेव डिपेंडेंट
स्लेव डिपेंडेंट है वो तो एड्रेसेस डिफरेंट होंगे ना.
चूज करेंगे
हाँ.
ठीक है स्लेव को एंड तो रीड करते टाइम ये हम एक बेस एड्रेस देंगे
हाँ.
फिर वो मतलब वो पॉप करता रहेगा
अब आप पॉप बैक करोगे ऊपर का डेटा नीचे आएगा आप सेम ही लोकेशन से.
उस केस में बस ये नहीं कर सकते कि बीच का डेटा
बीच
रीड नहीं
वो
कर
तो
सकते।
फीफो में बीच का डेटा वैसे भी नहीं रीड करोगे ना. वो तो फिर पर्टिकुलर इंडेक्स से आप रीड आउट करोगे.
मतलब फिर जिस सीक्वेंस में हमने एड्रेस की राइट रिक्वेस्ट डाली है उसी सीक्वेंस में हम रीड रिक्वेस्ट भी
इट्स
डालेंगे।
ऑल अबाउट आप फीफो जैसे नॉर्मली यूज करते हो
Right.
सेम वे यू आर यूजिंग विद द फिक्स बर्स्ट टाइप. ओके. Okay, so now what will happen in case of INCR? So INCR has some dependency on length as well. So if we talk about the INCR burst, so what are the possible value of AW length? In AXI3, the width of length is 3 down to 0. And in AXI4, it has increased to 7 down to 0. So the value of length can be possible from 1 to 16 beats for AXI3 and sorry, this is 4. And AXI4, it can be 256 beats. Okay. This is scenario for INCR. And in case of wrapping burst, we can have only
816.
24816.
24816. रैप में मैक्सिमम बाइट्स कितने ले सकते हैं हम 16 पे डिपेंड करेंगे
बाइट. हाँ वो तो सब पे डिपेंड
16
करेगा.
इनटू हमारा साइज
Size.
जो होगा वो
Wrap
भी
bound
7 टू इस पर 7 इनटू 16 2 हो जाएगा.
साइज
128 बाइट्स दे सकते हैं ना
मैक्सिमम. वही तो वो कह रहा है 2 के बाद 7.
16 into 2 की पावर 7
16 इनटू के बाद
हाँ हाँ करेक्ट. इधर 2 के बाद 7 साइज
size
इज
के
फॉर
लिए
1
better.
बीट.
नंबर ऑफ बाइट्स
मतलब एक
128 बाइट इज 1 बीट. ओके. सो ओवर हियर ठीक है साइज पे आते हैं अभी. ठीक है ये वाला क्वेश्चन रिटेन रखना. This is clear length, like these are the possible values of length in case of wrap and INCR. In AXI3 we have 3 down to 0. In AXI4 we have 7 down to 0, 1 to 16, 1 to 256. And for wrapping burst, because we have to calculate the wrap boundary and all that, so there is only 4 possible value, 2, 4, 8 and 16. Now if we see a incremental burst, size is 2, length is 3. Okay, this particular write transaction. Now this is over here. D1, D2, D3, and D4 are going. So address is, let's say we consider 1, 4, not 1, 0. So how the data will be stored in the memory? 0 cross 1, 0, 0 cross 1, 4, 0 cross. From here, D1, D2, D3, D4. So the slave will get to know the starting address. Based upon the starting address, it will calculate the next address. We know the size is 2. Size 2 means 4 bytes. So 4 byte of data can be stored in 1 bit. It will automatically calculate the next address. At the 1-8 location, it will store the next data beat. And at the 1C, it will store the D3. This is a incremental burst. And if we have more length, so it will go to 20, 0 cross 20. It will store the D5 beat or D6. So it will keep on incrementing up till the whatever the length is there. नहीं अभी आएगा aligned unaligned. ठीक है इसमें is there any doubt in this how the incremental burst is working?
No, sir.
Team Mukul.
For me, it's okay for incremental
Yeah.
burst length.
Okay, so I think it's clear to everyone. So, Abhi, can we schedule a next session for the rest of the things? I think there's a lunch time for you as well. It's 2 p.m. I think in Vietnam.
We already have lunch, sir.
You already had lunch. Okay, that's great. So we can continue more for at least half an hour then.
Yes.
Okay, sure. So, okay, then हाँ डैप का मैं वही सोच रहा हूँ बताने वाला मतलब एक तो अलाइंड अनअलाइंड है नहीं रैप इनका पहले बता दूंगा now we consider a third that is 0 cross 0 4 and it will be a graph 2 and 3 okay इसको थोड़ा कट शॉर्ट करेंगे एक बीट कर So this will be our third wrapping burst. Okay, the data is coming. The request is generated now in 04. The size is again 4 byte. Length is 3. 3 means 4. Okay, so like if we see, we have generated the 4 beats. So we have to pass 3 over there. So now how the data will be stored in the memory for this? We'll start with the 4. So D1, D2, D3. Now this F will be our, not F, sorry. This is not 20, no? I made a mistake, no one noticed, huh? This will be the addresses, correct? D4. RAM. So now we can see the difference in a increment or a wrapping burst. Now in increment, when we generated a address as 14, the data is going like from 14 to 20. Okay. So D1, D2, D3, it is going like that. But in case of wrapping, what will happen? The first bit will go on 4, 8C. Then after the C, 10 will be your wrapping boundary. So that will wrap the address to 00. So the last bit will be stored at D4. Now, how we are going to calculate this wrapping boundary? So there is a formula in the spec using the length, size, and your data width. We need to calculate what is the wrapping boundary, what is the lower boundary, and what is the upper boundary. So when the lower boundary get hit, so over here 16 is the last address, 0f is the last address, upper boundary is 00, so we'll store the fourth bit on the 00 address.
लास्ट बाउंड्री आएगी upper boundary से कंसीडर नहीं करेंगे मतलब उस पे राइट नहीं करेंगे
करा तो यहाँ पे 00 पे
नहीं लोअर बाउंड्री पर
लोअर बाउंड्री पे ये सी है तो सी
बट 0f होगी ना इसमें बाउंड्री
अरे 0 सी डी ई एफ आपका क्या है 4 बीट सी से स्टोर हो रही है ना ये एफ मतलब ये भी उस दिन संजीव के साथ हुआ था एफ इज लाइक कि आपका लास्ट एड्रेस है
उस पर नहीं लिखेंगे
लिखेंगे हम सी
ओके
सी डी ई एफ 4 बीट पूरी कंप्लीट 4 बाइट कंप्लीट हो गई है वो लास्ट आ गया अब वो 00 जा रहा है So this basic difference is clear how the wrap is working, how the INCR is working. INCR no need to consider the boundary. What is the boundary? It will just keep on incrementing. But wrap, we have to consider the wrap boundary. Any question on this thing?
So, what is the advantage of the grabbing bus laser, and when we use this grab and when we need to use increment?
So at what time we need to like use the increment and when we can use the wrapping burst?
Yeah.
Okay, we have one answer like we can use it for when we have a cache.
Like we have to control that इतने से इतने एड्रेस के बीच में ही हमारे राइट हो सकता है because we can't access other addresses.
That's what like cache है हमारा.
Utilize the whole memory.
We can utilize the whole memory. So increment, like mostly we don't, when we are not considering, we have like whenever we are accessing a slave, a directly memory. So if we see the memory, na, like most of you have worked on the memory protocols as well, I think. So you know there is a concept of the pages. There we have the banks, rows, and column. So we have a defined range within a for a specific address. थोड़ा सा. So whenever we don't need to consider that, so we use the increment at that time. Okay. So we just keep on incrementing the address location, but there is a condition of a 4K boundary. 4K, 4KB. So whenever a burst is being generated, a slave should not cross this 4K boundary. So what is this 4K boundary? Like in a particular burst, like there is a possibility a slave can have the memory size more than this 4K. Maybe it is a 128 KB of memory, okay, of the address range. But whenever a transaction is generated at the lower side on the last, if it is generated of, let's say, from 127 KB of address that is being generated, of 2 KB transaction is being generated. So at that time, the 4K boundary is getting crossed or not?
It will get crossed.
So only the incremental, we need to take care about this 4K boundary. But in case of wrap, when we have the cache lines, if we in the NOC in the master, if we have the cache line, so in the cache line we have the fixed addresses. So on a cache line we have only a particular index tag. So over there we have a fixed number of address and fixed number of data can be stored. Now let's say this 04 address, we can store data of like 16 bytes. Okay, so this is a cache line. Particular cache line is there. Address is 0x04. So we cannot now the next address can be 0x08. So or any other address as well. So it will allocate it in the if we go in the concept of cache, वो आपको every address it will allocate. ठीक है. So यहाँ पे now let's say we have generated in the middle like D1 is generated, D2, D3. Okay. Now we cannot go beyond this because cache line doesn't support it. We are going to some different cache line, which is not possible. So we have to utilize this only. For that, we just utilize D4, the starting. So the complete memory is being occupied. That's how we are just calculating the wrap boundary.
मैं तो इस बदले का हंस रहा हूँ
कुछ भी नहीं था. Okay, you got the answer, like who asked the question?
Yes, so depend on the kind of the memory, we will use the different bus lane type, right?
Yes, and mostly whenever there are caches in between the NOC and the and the master, at that time to utilize the complete memory, then we specifically use the wrap burst. But if we talk about the SOC, in mostly in SOC when we are performing the bulk data transfer, like everyone I think aware of all these terms, whenever we are performing the bulk transfer with the DMA, whenever the PCI is transmitting or receiving the data, DDR is transmitting, everyone use the INCR burst because the data is huge. It is not completed within the beats of 16 of the wrap burst. Okay, at that time we don't need to take care about the length, so we just need a wider data, so every time we use the INCR burst.
You said
What is,
you have a size, 4 KB, but it should wrap around it. Like it should be wrapping. So INCR में 4 KB नहीं काम करेगा.
नहीं, उसमें भी करेगा. ये स्पेसिफिक इट इज लाइक 4K का
नेट एक जगह दिखा तो वो दूसरा बर्स्ट इशू कर देगा. हाँ, मतलब वो 0 से स्टार्ट कर देगा बट दूसरा बर्स्ट होगा, मतलब रिस्पांस दोबारा आएगा, वो 8 के लिए चलेगा पूरा ट्रांजैक्शन.
जैसे ये हमारी पूरी 128 KB है, ठीक है, इसमें मल्टीपल 4 KBs हो गए ना. सो अगर आपका यहाँ पे इन बिटवीन स्टार्ट हुआ है तो वो इससे क्रॉस नहीं होना चाहिए. या फिर नेक्स्ट पे आ जाए वो।
अगर इंक्रीमेंट है तो फिर सर हमें मतलब उसको कंस्ट्रेंट करना पड़ेगा ना, मतलब उतना ही जनरेट होना चाहिए।
हाँ।
अगर उसके नीचे जाना तो अलग से वो ट्रांजेक्शन जनरेट होगी।
जनरेट
अगर सर
वही
उससे
कंस्ट्रेंट
बियॉन्ड जाएगा तो वो नेक्स्ट पे जाएगा या
नहीं, वो स्लीव एरर होता
तभी तो वो नहीं जा पाएगा 4 की कंस्ट्रेंट
दोनों में नहीं जा पाएगा, आईएनसीआर में भी होगा,
रैप में तो रैप हो जाएगा।
इस जगह पे बहुत
है। आईएनसीआर में जाएगा।
आईएनसीआर में सिर्फ एक पे ये मेंशन था कि वो जाता है पर वो दूसरा बर्स्ट इशू कर देता
हाँ, तो वो न्यू ट्रांजेक्शन वही ना, वही तो मैंने बोला ना, नेक्स्ट पे जा रहे हैं तो वहाँ पे न्यू ट्रांजेक्शन
है, पर वो स्लीव एरर भी था।
नहीं, स्लीव एरर नहीं है। न्यू ट्रांजेक्शन मींस आप व्हाट इफ आपने स्प्लिट कर दी ट्रांजेक्शन को। So we have covered length, burst. One thing is remaining is size. What is the width of size is 2 down to 0. Possible values 0 to 7. Okay. What it denotes is 1 byte, like 2 to the power size is that number of bytes we are sending in 1 beat of transfer. Size denote the number of bytes we are sending in a 1 beat. Over here, when the size is 2, 2 to the power 2 is 4. So 4 bytes we are sending in D1, 4 byte we are sending in D2. So overall 16 byte is being transferred in one burst. Okay. Nam. Any doubt in this?
No, sir.
Okay, so one basic thing, if I have to transfer, you have to tell me, let's say I want to transfer 128 byte of data. 128 bytes I want to transfer, I want to write. So what can be the possible value of AW length, size, and burst? Starting address, I am saying it is 00. What are the possible values of, not all the possible, give me one set of values. There can be multiple possible. Question is clear, na? That
Yes, sir. I know, sir.
yeah, the question is clear.
Yeah.
So tell me about the length, size, and burst, what we can send.
So one case that we can have AW length equal to 7. By
Length is
AW
7.
size
Okay.
is equal to 4.
4.
And we don't need to care about birth because you just need to send 128 byte. Birth can
Okay,
fix
we can
or
consider. Okay. So according to AW size 4, how many bytes are we sending in one beat?
16 byte will be sent in one bit. And we multiple with 8 and then we have 188.
Sorry?
AWLAN is AWLAN is 7, so we have 8 bit.
Yes, 8 bits.
Yeah.
one bit हो जाएगा ना size 7 bit
size 2
So let
length
zero
and
AWS values.
Other solution they are sending will give length 0, size is 7.
That's my length 16.
But now the other constraint we need to take care about the size, AW size, I missed, about the W data. What is the width of this W data that we are sending? Because it is also, it can be like, it can be anything. It depends upon the user. It can be a 512 bit, it can be of 128, 256, 8416, all the up to 1512.
size should be less than the data bus.
Less than or equal to. So in this case, if I am considering a width of 64, 63 down to 0. So you understand, na? Like this width of data, it should be less than or it should be equal to this AW size, because in one beat, if we have the data more than 64 bit, this is bit, so then it will be truncated. So this is not the possible scenario in this case. Is this valid then? ये वाला valid है?
Sir, 816.
हाँ.
Size की value 16 होगी.
size का क्या
Size 16 होगा. Size का maximum
64 कर सकते हैं ना इसमें
Size can be 1, 2, 3, 4 any possible, उसके according आप length calculate करो. Correct? So I think abhi, like, so far we have covered all the basic things of how the protocol is working. Okay. Now the remaining topic, the advanced
Sorry,
topics,
sorry,
we
a
can
little bit.
say.
So if the
Yes.
W data width is 64 bit, then AW size can equal to 4.
4 means
I think so.
how many bits?
For me, 16 byte.
16 byte have 64 bits bit.
No. 16
then-
byte is 128. 128 bit.
So
So AW size just can is 3.
according to 3.
So there should be two different transactions for that
Then it
command.
has 8 bytes. 8 into 8, 16 bit.
Yes.
Is
So
this
if
valid
it
now?
is increased, then we need to calculate another transaction with the increased address to complete 128 byte.
Yes. Like over here now, according to this length, only 0, the size can be 0, 1, 2, and 3. 0, 1, 2, 3. Because 0, either 1, 2, 4, and 8 bytes can be possibly transferred. Okay. And according to that, we can calculate the length. If we have 1 byte, then we can have the 64 length, no, 128 length. Otherwise 64 and 32 and 8. Okay.
Data and size. Data and size will be.
या तो मेरे से करना है एप्लीकेशन में कन्वर्ट कर लो एक हाई पार्टी तो या तो साइड से कंट्रोल से सीधे लेयर को साइड में
So tomorrow we'll continue for this AXI. Meanwhile, you can just go through all these points. Okay, and tomorrow we'll discuss all the topics of out of order transaction, outstanding transaction, data interleaving, and narrow transaction, partial transaction, how the scope is working. These 5 6 topics are there that we'll cover tomorrow, and then we'll go through the questions. Okay, but these are the basic things like how the protocol is working. I think the things are clear to you. Any doubt so far in the complete session anywhere?
Like sir, in fixed burst.
So
in fixed burst, sir, I have a basic question, sir. How the data will be on the same address, sir? Means D1, D2, D3, D4 in.
तो फिक्स में जैसे हमारा लाइक वी हैव फीफो ना, तो फीफो का एक ही बेस एड्रेस होगा बिकॉज फॉर ईच इंडेक्स फीफो के अपने अलग अलग एड्रेसेस नहीं होंगे. सो आप जब फर्स्ट लोकेशन पे भेज रहे हो वो उसको पुश बैक कर रहा है या फिर पुश फ्रंट कर रहा है, तो वो अपने आप ही लोकेशंस को नीचे पुश करता रहता है ना, फीफो पे काम कर रहा है ना.
सो डिफरेंट एड्रेस के लिए डिफरेंट लोकेशंस तो है ना सर फीफो में, एक ही एड्रेस पे तो हम नहीं ऑपरेट कर रहे हैं ना सर.
डिफरेंट एड्रेसेस नहीं होते. इफ यू टॉक अबाउट द फीफो ना, उनके अलग अलग एड्रेसेस नहीं है वो, इट इज द सेम एड्रेस
बट डिफरेंट डाटा
दैट इज
स्लॉट्स
जस्ट द इंडेक्स. हाँ,
डिफरेंट डेटा स्लॉट्स है मतलब उसके.
हाँ,
एक ही एड्रेस के.
हाँ.
ओके सर.
ठीक है. So tomorrow we'll continue on all these topics. So meanwhile you can just go through all this basic structure and okay. मुकुल,
यस सर.
मुकुल आपको कल ऑफिस आना है यार, ऑफिस आ जाना कल.
यस सर. यस
हाँ. Any other question, or we can conclude, or we can end the session?
No, sir. Thank you, sir.
Okay. Thanks everyone.
Thank you.
Thank you, sir.
Thank you. Bye bye.